everyone, we will be studying Amazon Web Services Certified Solutions Architect Associate level exam. I always thought it would be great for me someone to read on YouTube and read through the question, ask me the question on the go, so I can practice on the go as well. So this is what we are going to do today. I'm going to read through the question. We will discuss about the answers. We will try to find the best answer and we will practice together. So let's start with the first question. A company is building an application in the AWS cloud. The application will store data in Amazon S3 bucket in two AWS regions. The company must use an AWS key management service, customer managed key, to encrypt all the data that is stored in the S3 buckets. The data in both S3 buckets must be encrypted and decrypted with the same KMS key. The data and key must be stored in each of the two regions. Which solution will meet these requirements with the least operational overhead? So least kind of sometimes mean we may have a couple of right answers, but we need to consider the least operational overhead. Create S3 bucket in each region. Configure S3 bucket to use server-side encryption with Amazon S3 managed encryption keys SAA C03. Configure replication between S3 buckets. So this is the first option. Create a customer managed multi-region KMS key. Create an S3 bucket in each region. Configure replication between the S3 buckets. Configure the application to use KMS key with the client-side encryption. Now I'm going to read the third option. C. Create a customer managed KMS key, an S3 bucket in each region. Configure the S3 bucket to use server-side encryption with Amazon S3 managed encryption keys, SAA C03. Configure replication between the S3 buckets. The last option is create a customer managed KMS key and an S3 bucket in each region. Configure the S3 buckets to use server-side encryption with Amazon Web Services KMS keys. Configure replication between the S3 buckets. The first option doesn't mention about KMS, key management services, and the second option is create customer managed multi-region KMS key. Multi-region should be okay with us. Create an S3 bucket in each region. Configure replication between the S3 buckets. Okay, configure replication to use MS key client-side encryption. B might be a good option. Create a customer managed KMS key as S3 bucket each region. Configure S3 buckets. The C option is mentioning create a customer managed KMS key and S3 bucket each region. Configure S3 buckets to use server-side encryption with Amazon S3 managed encryption keys. Configure replication between the S3 buckets. This it doesn't have that multi-region KMS key, so you need to do each region separately, and it doesn't fit with the least operational overhead. Create a customer managed KMS key and S3 bucket in each region. Configure the S3 buckets to use server-side encryption. Customer manage again gives me the same option. Customer manage for each region and server-side encryption with AWS KMS keys. Configure replication between the S3 buckets. And the last option, the difference between the C and D is you also use server-side encryption with AWS KMS keys, and the C option was use server-side encryption with Amazon S3. So in general, the correct answer says C. Community voted for B mostly and 56% and D for 42%. So for me it feels like B as well because it said least operational overhead. So let's see what the documents are providing us. Multi-region keys are required. The person who said multi-region is suggesting this document to read. Multi-region keys, which are keys in different Amazon Web Service regions that can be used interchangeably. As true, you had the same key in multiple regions. Each set of related multi-region set keys has the same material with the key ID. So you can encrypt data in Amazon Web Services region and decrypt it in a different region without encryption or making cross-region call to AWS KMS. So it felt like the same, because it mentioned the least, this might be the best option for us, and after each question we will go through the document as well. Multi-region keys in Amazon Web Services KMS service are also powerful solution, flexible and powerful solution for disaster recovery, global data management, distributed signing applications, active application that span multiple regions. So this is the document you can find in Amazon Docs as well. So let's go to the next question. A company recently launched a variety of new workloads on Amazon EC2 instances in its Amazon Web Services account. Company needs to create a strategy to access and administer the instances remotely and securely. Company needs to implement a repeatable process that works with the native AWS services and follows the AWS well-architected framework. Which solution will meet these requirements with the least operational overhead? A. Use the EC2 serial console to detect access the terminal interface to each instances for administration. Attach the appropriate IAM role to each existing instance and new instance. Use AWS Systems Manager, Sessions Manager to establish a remote SSH session. Create an administrative SSH key pair. Load the public key into each EC2 instance. Deploy a bastion host in a public subnet to provide a tunnel for administration of each instance. Option D is establish an AWS site-to-site VPN connection. Instruct administrators to use their local on-premises machines to connect directly to instances by using SSH keys across the VPN tunnel. So it needs to match well-architected framework and it needs to be least operational overhead. EC2 serial console directly access terminal will not be the best option. Attach appropriate IAM role to each existing instance and new instance. Use Amazon Web Services Systems Manager, Session Manager to establish a remote SSH session. That might be an option. Create an administrative SSH key pair. Load the public key into each EC2 instance. Deploy a bastion host in a public subnet to provide a tunnel for administration. So D and C are kind of you provided tunnel for both of them. One is bastion host tunnel and the other one is VPN tunnel. But with the B, you use Amazon Web Services System Manager, Session Manager to establish a remote SSH session, which will be in their control with the role. So correct answer shows B. And community also voted for B. And let me see if there is a user guide, session manager, a document that we can go through. Session manager, Amazon Web Services Systems Manager Session Manager is a fully managed Amazon Web Services Systems Manager tool. With Session Manager, you can manage your Amazon Elastic Compute Cloud, EC2, instances, edge devices, on-premise services, and virtual machines. You can use either an interactive one-click browser-based shell or Amazon Web Services command line interface. Session Manager provides secure node management without the need to open inbound ports, maintain bastion hosts, or manage SSH keys. Session Manager also allows you to comply with corporate policies that require controlled access to manage nodes, strict security practices, and logs with node access detail, while providing the end users with simple one-click cross-platform access to your managed node. So this gives us all the information that we need for this question. So let's go to the next question. The company is hosting a static website on Amazon S3 and is using Amazon Route 53 for DNS. The website is experiencing increased demand from around the world. The company must decrease latency for users who access the website. Which solution meets these requirements most cost effectively? Cost effectively is the key here. So replicate S3 bucket that contains the website to all AWS regions. That doesn't sound like cost effective. Add Route 53 geolocation routing entries. Provision accelerators in Amazon Web Services global accelerator. Associate the supplied IP addresses with the S3 bucket. Edit the Route 53 entries to point to the IP addresses of the accelerators. Add an Amazon CloudFront distribution in front of the S3 bucket. Edit the Route 53 entries to point the CloudFront distribution. So for the global reach, and if the demand is not meeting, CloudFront is mostly the best option. Let's see if they have provided a document, but there is an explanation here. For the first option, as I mentioned, it's costly and complex. For the B option, global accelerator can be more expensive as it adds extra layer to infrastructure. Accelerators requires association IP addresses with S3 bucket. CloudFront already includes global edge location and provides similar acceleration capabilities. And for D, can help improve upload speed to S3 bucket but may not have a significant impact on reducing latency for website visitors. So yeah, this transfer acceleration can improve upload speed but will not be best for reducing latency for the website visitors. CloudFront is the best option, most cost-effective solution. It leverages CloudFront's caching and global contribution capabilities to decrease latency and improve website performance. I don't see any documents. So let's now move to the next question. The company maintains a searchable repository of items on its website. The data is stored in Amazon RDS for MySQL database table that contains more than 10 million rows. The database has 2 terabytes of general purpose SSD storage. There are millions of updates against this data every day through the company's website. The company has noticed that some insert operations are taking 10 seconds or longer. The company has determined that database storage performance is the problem. Which solution addresses the performance issue? First option is to change the storage type to provisioned IOPS SSD. Second option is to change the database instance to a memory optimized instance class. C is change the database instance to burstable performance instance class. D is enable multi-AZ RDS read replicas with MySQL native asynchronous replication. The answer for this question is B. It shows B, but community said A. So usually community is right on this page. So we will probably go with A, but we will need to understand why B is not the best option. Let's go through the answers together. So for answer B, changing database instance to memory optimized instance class focuses on improving memory capacity but may not directly address the storage performance issue. Option C, changing the database instance to a burstable performance instance class is suitable for workloads with varying usage patterns and burstable performance needs, but it may not provide consistent and predictable performance for heavy write loads. Option D, enabling multi-AZ RDS read replicas with MySQL native asynchronous replication is a solution for high availability and read scaling, but does not directly address the storage performance issue. Therefore, Option A is the most appropriate solution to address the performance issue by leveraging provisioned IOPS SSD storage type, which provides consistent and predictable performance, I/O performance for the Amazon RDS for MySQL database. So let's continue with the next question. This will be the last question for this video, and we will continue practicing later on again. The company has thousands of ad services that collects generative 1 terabyte of status alerts each day. Each alert is approximately 2 kilobytes in size. A solution architect needs to implement a solution to ingest and store the alerts for feature analysis. The company wants a highly available solution. However, the company needs to minimize cost and does not want to manage additional infrastructure. Additionally, the company wants to keep 14 days of data available for immediate analysis and archive any data older than 14 days. What's the most operationally efficient solution that meets these requirements? Most operationally efficient solution. That's the key. Create Amazon Kinesis data firehouse delivery stream to ingest the alerts. Configure the Kinesis data firehouse stream to deliver the alerts to Amazon S3 bucket. Set up S3 lifecycle configuration to transition data to Amazon S3 Glacier after 14 days. This sounds like a feasible solution. Let's continue. Launch Amazon EC2 instances across 2 availability zones and place them behind Elastic Load Balancer to ingest the alerts. Create a script on the EC2 instance that will store the alerts in a S3 bucket. Set up an S3 lifecycle configuration to transition data to Amazon S3 Glacier after 14 days. So there was the company needs to minimize cost and does not want to manage additional infrastructure. There was this requirement. It needs to be highly available. Create an Amazon Kinesis data firehouse delivery stream to ingest the alerts. Configure the Kinesis firehouse stream to deliver the alerts to Amazon OpenSearch service. Amazon Elasticsearch cluster. Set Amazon OpenSearch service. This may not be the cost efficient. Let me see if there's like something about the cost. Company needs to minimize cost and additional infrastructure. Does not want to manage additional infrastructure. So for OpenSearch service, that will be costly and additional infrastructure. Create Amazon S3 Amazon a simple queue service, standard queue to ingest the alerts and set a message retention period to 14 days. Configure consumers to pull the SQS queue, check the age of message, analyze the message data as needed. If the message is 14 days old, the consumer should copy the message to Amazon S3 bucket and delete the message from SQS queue. That is not going to be operationally efficient. So it looks like the answer might be A, and correct answer shows A, and the community also voted for A. Lifecycle transition general considerations section. Transitioning objects using Amazon S3 lifecycle. You can add transitional action S3 lifecycle configuration to tell Amazon S3 to move objects to another S3 storage. These are the questions we will be practicing today. I hope you enjoyed this video and you can leave a thumbs up. I will see you in my next video. Bye.